Alright, so I'm going to do an example for balancing redox and acid. I may have done one like this in the classroom, but I thought I would record me doing this so that if you got stuck, you could go back and look at the steps that I've done. The first thing that you want to do is you need to figure out the oxidation states of all the substances in the example that they've given you. Now, the sulfur -2 is pretty obvious. They're telling you the charge is -2. The chromium, they're giving you a charge here, and this last sulfur is also 0. So we do need to go back and find the charge of the substances here in the dichromate. So on somewhere else, we're going to take our CR2O7, which is -2, and we know that it has an overall charge of -2, and the 7 oxygens are going to contribute -2 each, so that gives me a -14 contribution from the oxygen. So I need to figure out my contribution from the chromium, and I know that whatever I add here needs to get me an overall charge of -2. So I know that this is going to be 12, and there are 2 of them, so this is going to get me, each charge is going to be a +6. So I can come back in here into my equation, and I can add that the chromium in that dichromate is a +6 charge. So now that we know the charges, we need to break it into our 2 halves so that we can see how the electrons are going to transfer. So we have a CR2O7 -2 charge will go to the chromium ion, the +3 charge, and we have our sulfur ion will change to sulfur neutral charge. So I like to carry along my charges to help me remember what I'm doing, so that whenever I go to do the electrons, I can see how many I need. So the chromium here, this chromium in the dichromate, is a +6. We need to double check to make sure that all of our atoms, not including hydrogen and oxygen, are balanced, and in the sulfur case it's 1 to 1, so we're good. This chromium, there's 1 chromium here, there's 2 there, so we need to put a 2 there to balance our atoms that are not the hydrogen and oxygen, which we'll get as part of this reaction. As doing that, everything's good now, so we need to move on to determining where the electrons go. I'm going from a +6 down to a +3. In order to do that, need to have electrons on this side, and I have each one of these chromiums is going from +6 to +3. So that would mean each one would be changing by 3 electrons, but there's 2 chromiums in the overall reaction, so I need 6 electrons on the left. And then in this other reaction, I have a -2 to a 0, so on this side I'm going to have 2 electrons for this half reaction. You could take a moment and think about which one is being oxidized and which one is being reduced. This is not part of the steps that you have to do, but if you remember oil rig, one is losing, this one is losing, so this one would be our oxidized, and this one is gaining electrons, so this would be our reduction. Sometimes they ask you to find that information, but in this case we're not doing that. Just a little side note. Alright, next step, we need to make sure that our electrons are balanced. I have 6 electrons in the first half, and I have 2 electrons in the other half. So in order for that to happen, for them to be the same, I can multiply this line by 3. So if I multiply this entire line by 3, I would have 3 sulfurs, 3 sulfur atoms, and 6 electrons. So what I like to do in order to help organize my thoughts, I'm going to go ahead and rewrite it this step, and that way I can follow my work a little bit easier. So I'm going to go ahead and rewrite out both half reactions with those changes applied. So 3s -2s makes 3s zeros and 6 electrons. Alright, so now we know that this is an acid reaction. So in an acid reaction, we're going to balance our oxygens by adding water. I have oxygen in this first half reaction. There are 7 of them. So on this side I am going to add 7 H2O, and I have no oxygens in the second half, so I don't need to do anything there. The next step is to add H+ hydronium ions, hydrogen ions, and I am looking here and I have 14 hydrogen ions, so I will need to put 14 H+'s on the left, and my second half does not have anything. So now we're down to the whole combine and cancel step. If you look here, I have 6 electrons on each side, and now remember the whole concept of redox is transfer of electrons. So I need to have my electrons cancel. They need to disappear. They are not to stay in this reaction at the end. Sometimes you have the ability to cancel other things within, or even combine. If the hydrogens had been on the same side, I could have combined them, but they're not in this case. So I'm going to rewrite the end answer, 14H plus, and I have dichromate, and I have sulfur ion, making 2 chromium plus 3 ions, 3 sulfur atoms, and 7 H2Os. So now this is my balanced redox for this particular reaction in acid medium.